Hello everyone, and welcome back to my channel, and welcome back to a new video. So in this video we are going to be covering Newton 2. So in this part, this is going to be a 4-part series. So in the first 4 parts I am going to cover the theory between Newton's first 4 laws of motion, and then in the second 4 parts, or in the next one, I'm going to be doing the mathematics behind each section of Newton. Now this is going to be 8 videos in total when we're done, but I just want to introduce the theory here and then get you guys familiar with the terminology and how the thought process works. So with Newton's second law of motion, we have this vector equation which states that F net is equal to m times a. Mass times acceleration is equal to the net force. So as we all know that force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second squared. Now the reason why you see these arrows over here is to indicate that this is a vector equation. And what we can do with this vector equation is that we can actually separate it into different components, our x and y components on the Cartesian plane, which is what I'll cover later on in the video. Now if you look at this object over here, I've got an object with a mass of m. Now we can safely assume that this object is moving across this horizontal surface and there is friction present. Now the two arrows state and they stipulate that the force and the acceleration always need to be in the same direction, because force is responsible for the acceleration. Force does not cause the object to move. Force always causes the object to accelerate in the direction of motion. Now if we apply a force of a certain number of newtons, this object is going to accelerate in that specific direction. So if I push to the right, the object will accelerate right. If I push to the left, the object will accelerate to the left. And what we're going to do in the second part is you're going to see that I'm going to show you guys the mathematics of how this works and how you can actually use mathematical principles to solve these types of equations to find the mass acceleration or net force, or essentially how we can also determine the tension in a string with Newton 2. Now, as I've stated before, that F net equals ma is a vector equation, and what Newton's second law states is that whenever an object with a certain number of mass is moving, the object will accelerate in the direction of the motion of that mass. So if we look at the component vectors over here, we can see that we can actually separate the F net equals ma equation into our x component and our y components respectively. Now if the object is moving horizontally, that would be taken as it is going in the x direction. Hence why the equation would be fx is equal to max, because we're dealing with our components in the x direction. If it was moving up or down or vertically, it would be fy equals may. Also want you guys to remember that the Newton 1 still does apply over here. The object, the matter of the normal force, and the weight force, gravity, which is pulling the object down. But specifically we're looking at the acceleration of the object when it is moving over here. So we all know, if we look at our Cartesian plane, we know that sine theta is equal to y and then cos theta is equal to x. We can actually use these principles to solve for F net equals ma or Fy equals ma, and I will show you guys that in the next part of the video. Another thing I want to make you guys aware of is that the object's mass will always influence the amount of acceleration an object will endure. Now if an object is extremely heavy, it will have a low acceleration, and obviously the amount of force that is needed to move that object will be extremely high, because the object in itself is extremely heavy, so it will need more force in order to move. If the object has a relatively low mass, it will be easier to move and the acceleration will be a whole lot easier. And I will actually demonstrate that to you guys when I actually do the whole mathematics behind this particular law of Newton. Now that is it from me today. I hope you guys have enjoyed this video. Please like, comment, subscribe, and share. If you have any questions, you may leave them down in the comments and I'll most definitely get back to you. Goodbye everyone, and I'll see you guys in part 3.